Okay, we can go ahead and get started. Okay, so I'm going to go ahead and record this and post it to Moodle in case you want to look at it later. I'm going to do it for the other two classes as well. I'll say different things every time. It's just how to make sure it is. And the questions will be different. So you may want to look at this video or the videos in the other two classes. Okay. So today's review day. I'm going to go over a few things and then I'll open up the floor for questions. Okay. The exam is going to be on chapters 1 through 4. 1/3 of the exam will be questions. It'll be primarily from chapter 1 and the beginning of chapter 2. Those will be short essay kinds of questions, like quarter to half a page. I'll talk about that first. And then the rest will be on programs. So it'll probably be 3 programs. Yeah, question? Okay. So if you have questions along the way today, make sure that you stop in advance. Okay. So for those short essay questions, that's going to come from the first chapter. And topics could include things like the difference between hardware and software, examples of hardware and software, what the CPU does, the whole CPU cycle of fetch, decode, execute, how main memory works, again, very in basic terms, the difference between system software and application software, as far as how computers store data. Yes. Yes. Yeah, it'll be on YouTube, but I'll post a link to the one. Okay. And this recording, making sure it's recorded. Okay. There will be a binary number conversion. Okay, so at least one. Could be from binary to decimal or decimal to binary. It won't be octal, it won't be hexadecimal. Okay. So all you have to worry about is the decimal, or sorry, the binary to decimal. How a program works, again, just the basic ideas between what machine language is, and then a compiled versus an interpreted language, and which one Python is. And, that. One thing that's not in the book, I don't think, but could be on the exam, is the different types of errors. Remember, there are 3 types of errors your program can have. Okay. And if I ask it, you would need to know the error, where it happens and who catches it. So the first type of error is a syntax error. We've all had those. It's where you type in capital P in print instead of small p. Those are like grammar errors of the language. Those are caught by the interpreter, and you cannot run a program with a syntax error. Okay. That's probably the most common error that we get. Second type of error is a runtime error. That's when the program runs, but there's a possibility that some condition manifests itself during the running of the program that causes it to crash. Most common one there is a division by 0. Okay. You can only catch a division by 0 or a runtime error by testing your program in what we call those boundary conditions, the big numbers, little numbers, 0, those kinds of things. Okay. The third type of error is probably the worst. It's a logic error or a semantic error. With that error, you just don't know what you're doing. Okay? You have a wrong idea of how something is supposed to work. It's the most damaging of the errors because your test will come out okay, right? You'll do exactly what you said you were going to do. The example I always give, if you think that square root of a number is dividing it by 2, you're going to create test cases. What's the square root of 8? Oh, it's 4. And you'll think that, you'll test it, it works, and you'll be happy. Okay. The only way to catch a semantic error is to talk to an expert or someone who knows the system. Okay, and they will be able to give you test cases that you can verify that will show that you've got something wrong. Okay. What's that? Syntax errors first, runtime error, and then semantic or logic error. The 3 kinds of errors. Okay. And then similar kinds of materials at the very beginning of chapter 2, and that's on things like the program development lifecycle. Okay. And I wouldn't ask you to memorize all 5 stages of that, but you should have a general idea how it works. Okay, be able to explain the process. You have to design a program, you have to actually code it, Then you have to correct the syntax errors that you have. Then you have to test it for any other kinds of runtime or logic errors. Okay, and then finally, you're done and you start over again. Okay, that's on page 31. Okay. This section also talks about algorithms. Remember, an algorithm is a step-by-step way of doing things. You can't write a program if you don't know how to solve the problem for one case on paper. Okay, so that's the start. How would I solve this problem on paper? From that, you can move to an algorithm that describes step-by-step what you have to do. That algorithm can be expressed in either pseudocode or flowcharts. We've used flowcharts in here primarily. So I could ask you to do a flowchart on the exam, or probably more likely, I could give you a flowchart and ask you to turn that into code. So make sure you understand the symbols of a flowchart, how that works. Okay. So as far as the programming goes, we basically have some tools that we can use to solve the problem. Okay. The tools that we have the print, we did print first, print function. The print function is going to take either string literals, things within single or double quotes, okay, or variables where it's going to give us a string representation of that variable, okay. And we can connect them with commas as many as we want, okay. Remember, we have some options over the print. The sep or separator determines what happens when we have a comma that separates things. Okay, so let's probably an example here would make the most sense. Okay, so if I have x is equal to 10, y is equal to 20, print xy normally. And it puts one space between the two. Okay. By modifying the sep, and you have to put a comma because it's like its own little thing. If I say sep is equal to nothing, then when I run it, it's going to cram those together. Okay. Which is probably not what we want. But you can do more spaces, you can do what you can do characters. I can do that. Okay. So now when I run it, it's going to put that in between. Okay. The other thing that we can do is we can change the end behavior. So if I do a print x, print y, okay, by default, when you're done with a print line, it does a new line character. Okay. So that's the end keyword. And end equals \n is the default, okay, for a new line character. But it could be something different. I could make it a tab. If I make it a tab, then when x is done, it's going to print out a new line, but a tab. Okay. Note that the second print still does a new line character. Okay. And again, you can put spaces there. You can put letters or whatever. Not that you want to, but you could. Okay. So that prints x. And then instead of a new line, like it normally does, it overrides that and prints those dashes. Then it prints that second line. Okay. Remember, if I print something like that is a string literal, okay, but I can also have a variable. It's now a string variable. Okay. So for variables, remember Python is kind of weird in that it allows us to change the type at will. So if I say x equal 10, I can use the type function to report that x is of type int right now. If I change x to 2.3, the type of x is now a float. Okay. If I set x equal to Bob, the type of x is now a string. And finally, I could set x equal to true. And the type of x is now Boolean. Okay. And those are the variables that we've dealt with so far. Remember, a variable is kind of a misnomer. We always say variable, but what a variable is in a programming sense, it's a label for a memory location. Okay. Our code should have comments. We use the octothorpe for comments. So every program you do should have name, your name, what the program does, stuff like that. So even on the exam, you should have those kinds of things. Okay. If you don't know anything at all about programming, but know how to do comments, you're going to get some points. Not a lot of points. You'll get some points. Okay. And in the same sense, if your program's perfect but you don't have comments, you're going to lose points. Okay. So make sure the comments are in there. Okay, what else have we got? Variables have certain rules on what they can be named. Okay, the keywords can't be used. Of course, I can't name something if or for. Okay, variable name can't contain spaces. The first character has to be a letter of some sort or the underscore character. After that, you can add in numbers, but that's it. Okay. Remember, of course, that a small x and a big X are different variables. And for longer words, we can either do like the first name like that, or the camel cats like that. Either one is okay. That is not okay. Can't have space. Okay. Reading input from the user. Remember that if we do something using the input command, the basic idea is here we're going to add a prompt. Okay. So what do we want to say? Remember, the input always returns a string. Okay, so this isn't really a number, so I would have to enclose it with either the int function or the float function, either one. Now it's going to actually return what we expect. Your prompt should be meaningful, should be something that makes sense. Note that you can't do complicated things like that. It seems like that gives an error. I know it's a restricted what you can do, maybe it won't. Oh, that's okay. Other things I've tried to do, you can't do. I think you can't do a comp. I know something doesn't work. Yeah. So no comments, no separators, no ands, none of that stuff. So remember, you have to convert those if you're going to be doing like okay. And also, sometimes in your programs you're not doing this. If you don't do this, I mean, it's still going to work as far as it's not going to give you an error. You know, a number, okay. But I've done nothing with the number. Like the number is gone. I can't do anything. So you have to assign it to a variable if you want to hold it. Okay. We can do calculations. Remember, we can do a plus, we can do a minus, we can do the asterisk for multiplication. We have options on division, right? We can do an example here. So if I were to do 9 divided by 5, with 1 slash, it gives me a 1.8. But if I do 9//5, that's integer division, this gives me that 1. Okay, this gives me the integer portion of it. That's related to the modulo operator or the remainder. So if I say 9 mod 5, that's going to give me a 4. Okay, because if I divide 9 by 5, I'm going to get a 1 with 4 as a remainder. Okay, and that's where that comes in. Other things we can do, the star is a square. Okay, I can do a star to a fractional like 0.5, and that's a square root. Okay. Remember that the order of operations are parentheses first, followed by exponentiation, followed by multiplication and division, followed by addition and subtraction. Okay. That's the order things will go in, just like math. All things being the same, it's going to go from left to right. Yes. What is the double divide and the double divide is an integer division, and it returns just the whole number portion. So 9 divided by 5, 9//5, returns a 1. That's the whole number. Okay. And then the 9 mod 5 returns the remainder of that. And that's because there's 1, 5, and 9, but there have been 4 left over. Okay. One thing you have to be careful with is that the exponent is going to hit before the multiplication. We had a problem on one of the financial things we were doing. You have to put the multiplication in parentheses or the exponentiation line. Okay. So if an operation is performed on 2 ints, the result's an int. If it's performed on 2 floats, the result's a float. If it's performed on an int and a float, then that int value gets temporarily converted. Okay, so really, if we were in a different language, I couldn't say like 5 times 2.3. That wouldn't work. Okay, but Python, again, it wants to be the cool mom. Okay, it's going to temporarily convert to the 5 to a 5.0. Multiply float by float. Our answer is going to be a float. Okay? So we don't have to convert. Okay, I don't have to say. I could say, but I don't have to. Float 5 times 2.3. So it does that for us. Okay. Just like that stuff. Remember, there are escape characters. We use the most common is the \n for a new line or a line break. \t is for a tab. You can do a / for the quotes if you ever need them to be literally there, or a \\/ if you want it to be an actual \. Okay. You don't see that a lot. Sometimes. Okay. On our print, I didn't mention it, but I should. We have the format string we have to worry about. Okay, we've done the separator and we also have the format. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, if I want to print X normally, it prints it just like I have it. Okay, but I can also print with the format function. Okay, so and we can do format on its own. Okay, if I could say the format, it's going to return a string with some specification. Okay, so I can format what I want to print. I want to print X. Then it's going to give us the format string. Okay, so let's say I want it to be with 2 decimal places. So I can do 0.2f. And that returns a string with that formatted number. So I can put that in the print statement as follows. I can say print format. If I can type X 0.2f, and that will print that out. Okay. Again, if I were doing the format by itself here in a program, it wouldn't print anything, but over in the shell it will. But if I print that, that's going to work. Okay. The other optional things here, the first thing that you can have is a minimum number of spaces. Type it in there. I can do a format, and they have to be in this order. What are you going to print? The format string can contain optionally the minimum number of spaces, which means the print's going to take up 15 spaces whether it needs to or not. If it takes more, it takes more. Okay. I can then put a comma to force there to be a comma every 3 spaces or every 3 numerals in the output. Okay. And I can put a point, whatever I want for the decimals, an F for float. Okay. So if I do that, oh, I've got one more. Outputs. Okay, so I put in the comma, it moved it over, so it's taking up 15 spaces, and there are 3 decimal places. And note that it rounded, so instead of the 0.678, it's at 0.679. What's that?
Where's the movement?
The movement, it's because I said 15 here. So it's going to take 15 spaces.
Okay.
No matter what. Okay. You do that if you're laying out columns. Okay. Remember, we also have the named constants. A named constant, if there's something like a tax rate, you put it in all caps, and it's, that would be a crazy tax rate. If a programmer sees something in all caps, even though Python doesn't enforce it, they should take that to be a constant. They shouldn't change. That's the idea. I just give it. Turtles will not be on the exam. So on to more things in our toolbox in chapter 3. And chapter 3 is going to deal with decision structures. Okay. So remember the basic idea here with our code that the normal structure we have is called sequential, like this one. It does this one, then this one, then this line. Okay, sequential means in order. That's how we normally do things. Okay. To break that up, the first thing we can do is to do selective. So we can say if C is greater than 100, for example. So that expression to the right of the if has to be a Boolean expression, which has to evaluate the true or false. Okay. I can't say that because that's the assignment operator. Okay, but I can say that. Luckily for us, unlike C++, Python will flag the 1 equals as an error. C++ does not. Okay. So if I say that, then depending on the value of C, either this happens, okay, if the relationship above is true. I can also do an else, which will happen if false. And down here happens no matter what. Okay, remember, Python is pretty picky about spaces. So anything here, as many lines as I want, I can put 1,000 lines here. If they're indented, they're all part of that first if part. Same thing down here, as many statements as I want. They're all part of the else. But when I'm back here, I'm outside of the else. So this allows us to do things in some cases and not others. If we need more options than that, we can always add in multiple conditions with the elif. Okay, when we do these, we have to make sure we do them in the right order because it's going to pick only one. If I put these in the opposite order and said first is C greater than 25, even if C were 200, it would pick that first one. Okay, so you got to be careful which one we go with. Okay. In an if-elif structure, as long as they're lined up the same, only one of the ifs or elifs or elses will ever execute, and always one. If there's an else, there's no else, nothing has to execute. So remember, for this operator, it could be a greater than, it could be a less than, it could be greater than or equal to, it could be a less than or equal to, or it could be equal or a not equal. So those are the options we have on building our Boolean expressions. Okay. Note that we can also connect these with relational operators. So I can say C is greater than 100 and some other variable X is greater than 10. For an and to be true, both parts have to be true. Okay. If I say or, then only one has to be true. Okay. I can also use the not. The not will return the opposite. Okay. So in this case, X is 10 if you look above. So X greater than 10 is false, but not X greater than 10 is true. Okay. And again, we can use Boolean variables. We can set them a couple of ways. Okay, we can just set a variable B equal to true or false. In Python, true and false have a capital first letter and that's it. Or I could set B equal to the result of some Boolean, some relational Boolean expression. So in the first case, B would be true. In the second case, well, these both aren't going to work. It's B. Oh, B is set to true. So, oh, C has value. C is currently whatever I input. Okay, so this will be either true or false depending on what I type in for C. Okay. And we'll see Boolean variables again here in a minute when we get to the repetition. Okay, so the last chapter we're going to cover is going to be on repetition, and that's the structure that allows things to happen again and again. Okay. So there are two basic types here. We have the condition control loop. Okay, and we have a count control loop. The while structure works for both. The for structure works only for the count control loop. Okay. So let's start with the condition control. Okay. The way these work, you have to, so let's say we want to say while x is less than 100. Okay. For this to work, x has to have some initial value, x equal to 1. So since it happens, since this is true the first time it hits, it'll make it into here. Okay. Here we're in the loop. We can then print x, whatever we want, as many lines as we want to do. Okay. But while we're here, we have to have a way to move toward the loop being over. We have to do something like that as a way to get us out of that loop. Okay. So this loop is conditioned upon x being less than 100. If it goes over 100, it stops. If we know how many we're going to do, we know we're going to do something 10 times. Okay. I can do it with a normal, I can do it with a while loop, kind of a long way around. I can say while x is less than or equal 10, I can then print x and set x equal to x plus 1. Perfectly okay. Again, the quicker way here is with a for loop. Okay. So the first way we learned, which is still valid for x in, I can just list them out as a list. That works. A for loop can't have an infinite loop. It's going to go through what it does and stop. A while loop, if I don't do this, for example, that's now an infinite loop. It'll never stop. Okay. The way we've been doing this more easily, though, is with the range function. The range function, it can take 1, 2, or 3 values. If I just take one value, this isn't quite what I want. It's going to go from 0 to 9. Okay? It assumes 0 if you don't put it. It goes up to, but doesn't include the top value. Okay, so it's 0 to 9 here. Or I could tell it where to start and go up to 1 more than I want. Okay? Or you can put the number in, either way. So that's going to go up 1 to 10, up by 1. The last one's a step. We can go up by 2. This would be 1, 3, 5, 7, 9. And it wouldn't go up. Okay, what else have we got? And again, you can all do whiles if you want, or you can do a for when they're necessary. Okay. We talked about a Sentinel value. That's just a value that's going to change in a condition control loop. And we also talk about the terminal condition. So in this while loop, the terminal condition is x being equal to 100 or above, greater than equal to 100. That'll stop. Every loop has to move toward a terminal condition, or it's going to be different. Okay. Questions so far? Okay, let's look at our input validation loop. Okay, so an input validation loop. Every time in your program you're asking somebody something, age is equal to int input age. You have to ask yourself, are there bounds on age? And yeah, a negative age makes no sense. The age of 1,000 makes no sense. We're talking about people. Okay? So we have to have a validation loop. We have to validate age. So it starts with asking for the age. We then are going to say, while there's a problem. Okay. So, and you have to ask yourself what is reasonable. And if you have questions during the exam, then let me know. Ask me, and I'll help you with that. But let's assume that the age can't be less than 0 It can be 0. You can be 0 years old when you're first born, when you're 5 months old. Okay. Or let's say age is greater than 120. Now I'm just picking that number. People may be able to live longer than that. We're just going to take that. So if either age is less than 0 or age is greater than 120, I know that I'm in an error state. Okay. So if I'm in this loop, there's trouble. So I have to print out an error message. And you'll see me do the same thing every time, just so I can remember it more easily. Okay. Age must be between 0 and 120. Okay, and then I have to ask for it again. When I ask for it again, you're now in an infinite loop. You never leave the error state. Okay. That will validate the age. Okay. And again, it's a validation loop because it puts you in that loop when there's an error, and it doesn't let you out to do the right thing. Or you get Control C. Okay. Okay, questions on that? Okay, the last thing then is going to be nested loops. And you can have a for inside of a while, or a for inside of a for, or a while inside of a while. It doesn't matter. Any of those work. But let's do what do we want? I guess we'll do the same example we did before. We'll go over it again. Let's say that we're going to have the student testing that we're doing. Okay, we want to do something for students. Each student's going to have 3 scores. Okay, so I can have for students in range. Let's say there are 5 students. Go ahead and print S. When you're doing your loops, you do one or the other first. Make sure it's working. Go 0 through 4, which is fine. We don't care about what we're doing there. We can say if we want print student comma S plus 1. Okay. Now we have our students listed there the way we expect. Okay. For each student, we want to have the tests be in the range, let's say 3. So when I get here, I can print our score is equal to input, int, input, just something in the module we're doing. Okay. And that's going to get us through. I'm not doing it until I get the idea. So I'm going to get for each student. What did I just do? And then for each student, you get the input 3 mistakes. Okay, and so forth. So how many times does that happen? It happens 3 times for each of these 5. So 15 times total. Does it ask? Does this line give them? Okay. And that's it. That's all you gotta know. Okay. So your task after the first short answer part or short essay part, you read the problem, make sure you understand it, work it out an example. Never hurts to bring some scratch paper. That's perfectly okay. To go ahead and write out what one example would look like. Okay, you can scratch out your algorithm if you want. Then use the tools that you have: the sequential, the selective execution, and the repetition to solve your problem. Okay, using using input with either an int or a float for your input, and then using the print for the output. Yes. The test, either you can use the computer in here or bring your own. You can bring all that out. Okay. I wouldn't recommend doing it on Python instead. That acts weird sometimes. You'll need to have a jump drive. I would, just to make sure you're saving your files. You can try to save them on the computers, but your best bet is having a jump drive. They're cheap. Okay. You have a question, Sam?
Yeah, real quick.
Sure.
I didn't think, are we doing for the short essays, any like flow charts in the drawing?
There could be, yeah. On the flow chart, either I could ask you to draw one, or probably more likely I could give you one, you'd have to turn into code.
Okay,
So be familiar with them. No pseudocode though, we haven't really stressed it much.
okay.
We'll wait the algorithms for that.
And then, for the text, you said it's the footings on this, but are
Yes.
we gonna have like a paper part for the written? thing?
Yes, the written part will be on paper.
Okay,
Yep, then you'll turn that in, and then you'll move to the computer.
okay,
And your computer will be off during the first part, you turn it on for the second part. Okay. Remember, there's a cheat sheet out there that you have every right, and you should print it out before the test. Once you're here, you can't, unless you want to take time out off of your exam and go get it, make sure you have a copy. Okay, you can't share with people, bring your own. Yes.
Right on that copy.
Nope, you cannot. All you can do on the copy is highlight stuff that we can do, that we've done. Okay. Because some of you have discovered the break command, you can't use it on the exam. Okay, because I want you, because it forces you to do different things when you don't use the break command. Okay. So only commands that we've talked about are fair. Okay. Other questions? Okay, let's call it a day. I've recorded this. I'll put it out there. I'm around today. I've got office hour. I actually teach from 1 to 2 today, but I'm around more or less now until 1. I'm also around this evening and tomorrow, all day tomorrow. I will be here, but you can text me. We can Zoom if we need to. Okay, see you guys on Friday.